Hi everybody, so this is still page 60. It's the second example on this page. This one's a bit more detailed and a bit more typical of what you're going to see in the exercise. So let's have a look and break it down. We've got a man of weight 600 newtons. He's standing on a footbridge that consists of a uniform wooden plank. It's just over 2 meters long and the plank weighs 200 newtons. We've got to find the reaction force exerted on the plank when the man is 0.5 meters from one end. Okay. So let's draw it out a little bit. We've got a little footbridge, just over 2 meters long. The reason why they've worded it like this is they're saying that the distance between the two pivots or the two fulcrums here, that's 2 meters. And we need it to be just over 2 meters, just so that the plank doesn't sort of fall through, if that makes sense. We've got the man standing 0.5 meters away from one of the edges. Let's put him here. Here we go. He's got a single eye, it seems. Yeah, that's fine. That's 0.5 meters here. 0.5 meters. And he weighs 600 newtons. And there's also a weight for the plank itself. So the plank, because it's uniform, it means that the wood sort of is like of a consistent sort of not texture, but like density, I suppose. Yeah, density. So the center of gravity for a uniform plank will be exactly in the middle. It's not heavier on one side compared to the other or something like that. And since the plank is 2 meters long, we'd expect this distance here to be a meter. Now, in terms of our forces here, we've got 600 newtons and 200 newtons acting downwards. If the system is in equilibrium, i.e. the man doesn't like sink through the bridge or break the wooden platform or whatever, we require some forces going upwards as well to balance out. And we've got two. We've got a reaction force at A, and we've got a reaction force over here at B. Sorry, I should have labeled these A and B. Here we go. So that's our setup there. And we're going to try and find out what these reaction forces are. Okay, let's start this. What I'm going to do is I'm going to find all of the moments from this point here. There's a few to work out. Let's start by considering the weight of the man. We're starting here. The man weighs 600 newtons. He's a distance of 0.5 away from the fulcrum. And if we work that out, it'll come to 300 newton meters. That is going to be relative to this point. It would be clockwise. There's also the plank itself, which is a 200 newton force times by a meter gives 200 newton meters. And again, that's going to be clockwise. And then we need to consider the reaction forces. Now, because I've decided to consider the forces from this point here, from A, even though there's a reaction force here, I don't need to consider it because the distance is 0 from there. So I don't need to worry about this force. I will need to think about this one though. So the reaction at B is as follows. The plank is 2 meters long, so this distance is 2 meters. I'm going to have reaction at B, that's the force, I don't know it yet, times by 2, and I'm just going to call that 2RB. And that force is acting anti-clockwise relative to the fulcrum over here. Since this situation is in equilibrium, I can equate the clockwise and anti-clockwise moments. The clockwise moments are 300 and 200. The anti-clockwise moments are 2 times the reaction at B. I'm going to get 500 equals 2 lots of the reaction at B. I'll be able to divide by 2 and get the reaction at B out as 250 newtons. If I wanted the reaction at A, I could repeat the whole process starting from the other edge, but I don't really want to do that. There is a faster way, and what we can look at is we can consider the forces. Okay, we know it's in equilibrium, so the forces up and the forces down should also be equal. And we know that the forces are 600 and 200. Oh, they're down forces, aren't they? Oh man. All right, okay, that's fine. We'll fix that. Like it never happened, guys. So 600 and 200 down, and the forces up are the 2 reaction forces. I've worked out one of them already. If I just rearrange this equation a little bit, if I do 800 minus 250, I'll get, what's that, 550 newtons. Yeah, great. So I think that's to be expected. The man is closer to this fulcrum here, so you'd expect more of the force to be sort of on that one there.